Hi, everyone. It's my pleasure to welcome you back on behalf of the Russell Sage Foundation, the Alfred P. Sloan Foundation, and Duke University. We're back at the Summer Institute in Computational Social Science, and hello again to everyone on the live stream. So earlier this morning, we talked some about experiments, what they are, why they're helpful, and then we talked a little bit about some ideas we can use when designing our experiments that will potentially make them more interesting and more important. Now what I want to talk a little bit is about the different ways that I see people actually doing experiments and making them happen. So many of you, I hope, after seeing this stuff this morning, were thinking, great, I have this cool idea, I want to do an experiment. How should I get started? And so I want to talk about the different ways I've seen people do experiments in the digital age. So to be clear, I'm going to talk about 4 main strategies, but none of them are perfect. So I think sometimes people think, oh, if I could just partner with Facebook, I could do the perfect experiment. And I think that's generally not the case, that many of these things involve trade-offs. So I think I'm going to talk about 4 main trade-offs. I want to define each of these terms. So first is cost. And so cost, this includes the cost that you have to pay to participants. It also includes the cost in your time and the cost in terms of getting everything set up. So money and time. Control, meaning the amount that you can use the treatments that you want. You can measure the outcomes that you want. You can control who is not the participant. Realism is sort of the extent to which the experiment is measuring the effect of some more or less naturally occurring treatment on some more or less naturally occurring behavior. And ethics is ethics. OK, so the first main strategy is what I like to call partnering with the powerful. So this would be trying to partner with a company. It could also be an NGO, a government, a political campaign. So in all of these things, these are people or organizations who are out in the world trying to do stuff. And they often are already running experiments or could potentially benefit from running experiments. And so if you can partner with them, you can potentially do the experiment that you want. Generally, these have low costs in the sense that the partner often bears a lot of the cost. But these are not free for you because there is often a large cost in you forming this partnership, making sure the partnership works successfully. Often the partnerships don't work successfully, so there's a lot of false starts as well in this. Control is medium. Certain times the partner will allow you to, you can often do lots of things, but the limitation, the control often comes from the constraint that the partner imposes. So for example, if you partner with Facebook, there are certain experiments they will just not let you run, and because that's contrary to their business interests. Realism is often high because these are real people who are trying to get things done in the world. And the ethics are potentially complex. So we talked some about what happens if the partner has a goal that you don't share. There are often issues that arise as well about intervening in real systems. And so this is not always problematic, but it can be complicated. One question that I get asked a lot is, how should I do this? Like, I really want to partner with someone. How should I go about doing it? We had a really nice discussion about it at lunch one day. And I want to talk a little bit more about other strategies that I've seen. So the first is, this is explicitly called partner. It is not called, I want people to give me their data. And so I've often heard people come and say to me, I want someone to give me their data. And I'm like, that's not going to work. I can just tell you right now, if that is how you're approaching this, it's not going to work. So think about it as a partnership. And Sanaz has a lot of great ideas about how to make it a partnership. So you should talk to her about this as well at lunch or dinner. Start with personal relationships. The way I like to think about it is, the person that you are asking for help is more busy than you. That should be your assumption. You should assume that if you're a graduate student, you should assume the person you're asking for help is more busy than your advisor. So they just are. And so I remember one time I had this idea. I thought, this is a huge company. surely they have an extra engineer who can spend a month working on my project. And so this is obviously a very silly idea. No matter how many engineers this company has, they are all 100% busy, or maybe 150% busy. And this is sort of the natural state of the world at these companies. If there are engineers sitting around not doing anything, those engineers will no longer be employed at that company. Or they will be assigned onto other things. Let's make it more positive. They'll be assigned to start doing stuff because every company has more stuff they need to do than they have time for. So you should assume for sure that everyone is completely overloaded and you're asking them to overload on top of an overload. One strategy that I've seen that's effective, especially for graduate students, is to do internships. So companies often would like to hire you permanently, and they view internships as one way to potentially hire you, at least in the short term. So a number of you, I think, have done internships at companies or at governments, and so this would be a good thing that we could talk about in one of the meal conversations. And then these internships are really good for understanding what is and is not possible, and starting off some of those personal relationships. Because actually, one of the other things I've seen is from the outside, it is very difficult to even know what is hard and what is easy. Because the way sometimes the data is stored, you think, oh, I'll just go. They must have all their data in one big, well-organized database. And then you spend some time there and you realize, actually, no, that is not the case. Certain things, they are easy, and other things are hard. And sometimes from the outside, it's hard to know the difference. And then the last is about finding Pasteur's quadrant. And so this is an idea that I think is very helpful. It's very related to this between optimizing experiments and understanding experiments. And it's also sort of about breaking down the distinction that many academics have between basic research and applied research. So this idea is really motivated by the work of Pasteur. And so let me just take a step back. So many people think there's basic research, and that's what professors do, and it's cool and important and beautiful. And then there's applied research, which some academics think is grimy and not worthy of our time. That's not what I think, but some people believe that. And I think the work of Pasteur is a great way of illustrating why this continuum does not exist. So his work about the germ theory of disease, which everyone would describe as very basic research, actually came out of work he was doing at a factory that was trying to turn beet juice into alcohol. So it was an incredibly applied problem. And so what was happening is in this factory, the processes kept breaking and stuff was blowing up. And he was like, why are these things all blowing up? Maybe there's some invisible organisms that are causing these kinds of reactions and causing this not to work as well as I'd like. And so is that work by Pasteur, is that applied or is that basic? It's kind of both. And so if you have a one-dimensional continuum, you can't really be at both ends of that continuum. So the Pasteur example might lead us to reconsider whether it is really a one-dimensional continuum or whether there's more than one dimension. And so Stokes has proposed instead that this is really a two-dimensional process. And so the two dimensions are whether there's a quest for fundamental understanding and whether there is a consideration of use. And so Pasteur's work, there was a quest for fundamental understanding, but there was also motivation, consideration of use. And so this is very different. A lot of, so generally I think as researchers, we often want to be in this row here where we are seeking fundamental understanding. And some work seeks fundamental understanding with no consideration of use. So the example that Stokes talks about is Bohr and understanding the structure of the atom. This was done without a consideration of use. It turns out to be very useful, but that was not what was a consideration at the time. Also, there's work that does not seek fundamental understanding, but is definitely motivated by use. So the example here is Edison. So Edison like did a lot of stuff, built light bulbs and all this other stuff, didn't really make basic scientific advances, but made huge advances in society and enabling us to enjoy a lot of the benefits of electricity. And so the idea is that if you are partnering with the powerful, the best place to be is here. You want to be in Pastor's quadrant. And to the extent that you want to seek fundamental understanding, and your partner is often very interested in use, and so there is a place for this in scientific research. Just because there is a consideration of use does not mean that this is not science or not research or not important or interesting. So that's about Pastor's quadrant. I would recommend keeping that in mind as you try to think about how you do these partnerings. Okay, so that's one approach, is partnering with the powerful. I often think that partnering with the powerful can sometimes be more trouble than it's worth. And so the other strategy is just do it yourself. Like, don't worry about all these people, just do it yourself. And so I think there are three kinds of designs for sort of three models for doing it yourself. The first is to just use existing systems and build your experiment on top of that. And so this is very low cost. It gives you generally very little control because you're not. Let me give you an example of this strategy first, and then I'll come back and tell you about the trade-offs. So actually, Sendel gave you the example yesterday. This was a study about selling iPods on an online platform, kind of like Craigslist. They don't name the exact platform, but it's something like Craigslist. And so they posted these different ads, and then they varied the hand that was included in the picture, whether there's a tattoo, whether there's a black hand or a white hand. And then they measured the effect of this on the probability that the I keep saying iPad, but there was no iPads then. The iPod would be sold, and also the effect on the price that it was sold for. And so in this case, this is a digital experiment. They were able to run it with participants all over the US, which was an interesting geographic variability, is something they analyzed in more detail in the paper, because they were using a system like Craigslist. And this did not require any programming. Like, they didn't have to do anything to do this. They basically took advantage of the digital infrastructure that existed and then put their experiment on top of it. And so here you have low cost because you're not trying to build Craigslist yourself. You're just using Craigslist. You have relatively little control because you don't control the platform. The realism is often high because you're working in an existing system. And the ethics are potentially complex, not always, but potentially complex because you're, again, you're entering into a real system. And so this is a use existing system strategy. Recibo and Van der Reydt also use that strategy as well. So this is something, you could potentially do this next week. I mean, not the whole thing, but like you can get started very quickly if you have a really nice way of attaching what you want to do on top of some infrastructure that already exists. The next strategy is to kind of build your own experiment, and this is one that I built along with some colleagues, Music Lab. I'll talk more about that in the next set of slides, but this involves sort of creating your own website where people can come and download new music. This is what we did, creating our own website where people could download new music. So this is much harder in terms of cost, but you get much, much more control. Like, we could have never embedded that experiment into an existing system because the kind of design we wanted to use, no system would have supported that design because that design doesn't make sense. And no partner would have likely allowed us to use that design because it's not a design that naturally aligns with the business interests of a partner. The realism is generally medium in the sense that often if you build your own experiment, people are coming to it and not as part of their daily life. And so you sometimes lose some of the realism that comes with naturally occurring behavior, but It's more of like a digital field experiment, and if you design it well, it can have kind of high realism. And the ethics of these are generally easier because you're really in control of the entire system. So you don't have to deal with a partner, and you don't have to deal with intervening inside of existing systems where you could potentially do some environmental harm. So I'll talk much more about building an experiment in the next set of slides. Finally, you can build a product. And so an example of this is the Movie Lens project. So in this project, this is run out of the University of Minnesota. They created a system where people could get non-commercial, personalized movie recommendations. They were doing this a long time ago before Netflix was doing movie recommendations. And so this was like, at its time, a very novel service that people legitimately wanted to use. People were like, this is useful. And so they have, I believe, hundreds of thousands of users. And this provides a sort of data that they can use for research. And it provides a platform on which they can do experimentation. And so this has the potential to kick off these kinds of virtuous cycles. So remember when I was talking about all our ideas, I was talking about a virtuous cycle. And so here you have a similar thing. So you do research, that helps you build a better product. Building a better product helps you get more users. And then you can get this virtuous cycle. So I want to be clear, though, this is very expensive. It's very hard to build something that people legitimately want to use, and that simultaneously helps you do research. So if you think about it, there are tons and tons of people in the world trying to build stuff that people want to use. And most of those fail. And then you have the added difficulty that it's also supposed to be useful for science. So this is a very, very difficult strategy to actually take. The control that you get is very high because you're the boss. And the realism that you get is very high because, again, you have people doing this not because they want to be in an experiment, because they want to get movie recommendations. And the ethics, I think, again, are relatively easy because, again, you're in total control. So this is the build a product strategy. I think it's very difficult, but to me it seems really exciting because if you can do it, which again I think is very difficult, you can really do stuff that would be hard to do any other way. So those are the 4 strategies that I see. None of them are perfect, but I really do want to emphasize these 3 strategies. That is, you don't just need to, you don't have to work with partners. You can do it yourself. And there are a lot of downsides that come from working with partners, and doing it yourself creates a lot of opportunities for more control. But you also give up stuff like the scale that you get from working with partners and sometimes the realism. So there is a trade-off, but both sides of this exist. You don't just have to work with partners. Any questions? Ike?
I'm wondering, when you're applying an experiment on an existing website, so you utilize their services, what is your view on the potential that there is like a selection bias of users going to that website, as well as like services that claim to analyze website traffic and what type of users are going to those websites, like Alexa.com?
Sure. OK, it's a great question. So if you do an experiment in an existing system, then you have to think about who are the users of that system. And so it's true that those users may be specific. So if I was going to do this, I think there's sort of 2 ways I would think about it. One is maybe I really only care about those users. So for example, you had talked some about Backpage. Is that what it's called? So Backpage, for example, it's now out of business, but you may care about users of Backpage more than you would care about a random sample of Americans. And so in that case, the non-representative population is a feature and not a bug. I think too often we think of simple random sample of the entire US population as the gold standard, but it's not the gold standard for lots of questions. For lots of questions, we want the actual population of people who are using a system. Now, if you don't have that kind of question, I think the second way to think about it might be can I replicate this on multiple existing systems? So let's imagine, for example, Craigslist. You might think, well, the people who are on Craigslist are different than the people who are not on Craigslist. That may be true, I don't know. So are there other Craigslist type platforms that exist? Like eBay, or I don't know, what are there are probably more. And can I replicate this experiment on multiple platforms? And again, because the cost, the variable cost is low, potentially you can replicate it on multiple platforms. And then I think that gives you a much stronger result than you would get from any single platform. I want to also talk about one complexity that comes from working on any platform and why I think multiple platform research is really good, is that sometimes the results that come from a single platform include algorithmic confounding. And so you have to decide whether you want algorithmic confounding or not. So let me give you an example. So in the Wikipedia Barnstar study, let's imagine that one of the things they measured is when you receive a barn star, do you also then get subsequently more barn stars? So if it turns out that Wikipedia ranks people by the number of barn stars they receive, then receiving a barn star might be more likely to give them another barn star, not because of any psychological reason, but because of the mechanisms at place in Wikipedia. And so lots of these online systems are ranking or prioritizing things for you. And so you have to decide whether you want those in there. So if you're particularly interested in like how Backpage works, then you probably want that in there. But if you're interested more in like psychological decision making, then you probably don't want those in there. And it's often very difficult to isolate them and figure out how those algorithmic decisions are being made by these platforms and control them. And so in that setting, doing it on multiple platforms is really helpful because it makes you more confident that it's not the result of some platform-specific algorithm. Yeah, Carson?
I feel like a lot of the stuff that we as CSS people do is some one-time analysis. So we have some Twitter data or some social media data. We run something one time, we analyze it, that's it. But with these platforms, you actually need quite a different skill set, right? You need to be able to deploy something which runs at scale potentially, and like building a product. So I, for example, would not be able to do that at the moment. And maybe you could tell us a little bit more about your experiences with wiki survey. So how did you actually come up with this giant thing that actually works now?
Yeah, so a number of these strategies require skills that we don't really learn. So building your own product or building your own experiment requires knowing stuff that we don't necessarily know. So all of us could learn that stuff. I'm totally confident if you can learn all the stuff you've already learned, you can learn how to build a website. It's not necessarily the most efficient use of our time. So I can talk a little bit about the different models that I've used in the past. So for all our ideas, I have hired a number of different web developers. So the way I like to think about it, and this was something that we sort of started in the music lab, my dissertation experiment, was like, there's a division between sort of getting the data into the database and then getting the data out of the database and doing stuff with it. And a lot of the stuff on the front end is stuff that I often have other people do that I would hire. So sometimes people think, oh, let's have undergrads do that. And my experience has been that undergrads generally are not going to produce a professional quality product. You might be lucky and find an amazing undergrad, in which case that's great. But if you want a professional quality product, you need to work with professionals. And the reason why professionalism, I think, is very important is that the standards for web design and product look and feel are incredibly high because most people interact with the most beautiful websites. So if you think about the websites we use most, they're like Google, the New York Times, Facebook. These companies have the best web designers in the world. And so that is the standard that people are used to. And so if you want to build something that looks and feels professional, you need to really work with professionals. So the problem, a problem, is that professionals are expensive. And so this creates one of these there's like a high fixed cost to build it. So I've worked with different models. So sometimes I've hired professionals full time. There's one model is like the Lone Ranger model. I don't know if so. There's like some people out there who are web developers who kind of work. They're like out looking for projects. They work for a few months and then they go surfing for a few months. And like some of these people are incredibly talented, but you have to find them when they're not surfing. And you have to hope that while they're surfing, generally they don't like dealing with bug requests and stuff while they're on their surfing time. So this is a model that's difficult. Another model is to hire someone full time, but then you need often a lot of money at the beginning to be able to promise someone a job. You often need to have that money. You often don't have that money at the beginning of a project. A third model is working with a company. So I have a company that I've worked with for many years, Agathon Group. They're awesome. They're the people that built allerideas.org, or they're the people that currently are working on allerideas.org. There are other people who helped build it along the way. They built the Open Review Toolkit. And so one advantage of working with a company is that they often have people with many different talents. So they have a front-end designer. They have people who can build a website. Those are generally different skills. If you're going with the Lone Ranger model, you need to find someone who has both of those skills, which is very, very, very difficult. So we can talk a little bit more about working with professional developers maybe at one of the meal discussions. I think it's a problem, it's a challenge, but I think if you want to be able to do professional stuff, I think it's really helpful to be able to work with professionals. Oh, is it a follow-up question or? Yeah, okay, Carson?
How did you then actually get people to use wiki surveys? So what's your strategy there?
Yeah. Hard work, I guess. I don't know. The same kinds of things that you normally see a company do. So I would go and talk to people. So initially, we tried to find some like well-known organizations that would use it. And then we could say to other people, hey, like the New York City Mayor's office is using it. And then everyone's like, oh, okay, well, that sounds great. So initially, it had to be a lot of, one of our first projects was with Catholic Relief Services. They wanted to do one in, theirs was really interesting. They wanted to do one in multiple languages because they had people all over the world working in many different languages. So we had to build the multiple language support for them. I mean, that was something we wanted to build anyway, but we had this client that was doing a cool project and we wanted then, so you have to be out and talking to people. This was a risky thing for the person inside the organization. So I actually went to their office and talked about it to get everyone there comfortable with it. And so basically treating these people like customers and doing a lot of the things you would try to imagine doing if you were starting a company. Now we're at the point where we have enough people who have already used it and it's up and running and it's stable and we're not needing to change features a lot. And so now it's more or less happening automatically without a lot of intervention by us. But at the beginning, it took a lot of work. Natalie?
I was just going to ask about grant funding
Yeah.
and research funding being used for web development kind of expenses. It seems like something that would be really unusual for a grant agency to see, at least in a grant from someone in my field.
So for all our ideas, the funding was from Google. And so they're like, yeah, okay. In terms of what that would look like from, let's say, NSF or NIH, I think Chris can talk about that.
Limit on contractors, which buys a lot, but probably not the cost of all our ideas. I'm not sure. It bought a good chunk of the last app I built, but that's a limitation. Yeah. So not sure about NIH.
Yeah, so $20,000 is not going to get you a product. But $20,000 can get you something, for sure. But the other thing when you're working with developers, you also need to think about not just the cost of building it, but also the cost of maintaining it. And so if you have a short-term experiment, then I guess maintenance is not as important. But for something like All Our Ideas, it takes a couple hours a month of maintenance to deal with new versions of the open source packages that we use and occasional user questions and so on. So you want to have a system where you're going to be able to do maintenance if you're going to have something that's ongoing.
On what was that Tuesday about how APIs often change. So you can imagine you build an app and then there's some change in some query field, the name of it changes, someone has to go fix that in multiple places. It's typical when you work with a firm like this that you'd get some kind of estimate for user support, and it's something that might not be in your thoughts as you're planning a project, but it's important, especially if it has to go over a long time frame. Again, if it's a one-off thing, it might be less.
Yeah. So one other thing, something about that, the estimates. So there's two ways of paying people, I think, or there's probably more than two, but there's two main ones. One is like you write a spec, and then you get a bid, and then they build the spec. And the second is paying by the hour. So I generally prefer to pay by the hour for a couple of reasons. One is I find that it's often very hard to write the spec because you often don't exactly know, especially if it's your first web development project. You almost certainly don't know what to ask for. And then often the project evolves and there's maintenance and things like this. And so if you have a system already set up paying people by the hour, then it works well. Now, some people say if you pay by the hour, then the person can maybe take advantage of you. But if you're worried about the person taking advantage of you, then you shouldn't be working with them anyway. So that's another issue in sort of working with contractors. Yeah? Sanaz?
I wanted to ask about timetable. Can you give us a sense for how much time it took to set up like Music Lab?
Yes.
And how that changes the way you think about the project timetable?
Yeah.
Relative to data cleaning and wrangling.
Yeah, so Music Lab, I'll talk about Music Lab in a second. That one took about 6 months to set up. And that included a professional full-time developer, Peter Hausel. To build Music Lab today would not take 6 months. So the other thing is that we were doing it in 2004, and a lot of stuff was just harder then. Also, we didn't exactly know what we were doing as we were building it. In other words, we were sort of designing it and building it at the same time, which is not the most efficient thing. So it does add more time, but we didn't have to spend a ton of time trying to find a partner. So if we were going to try to like go to iTunes or convince them to do it, that might have taken a similar amount of time and might not have been successful. Any other questions about strategies for doing experiments? If people want to talk more about working with contractors, we can definitely throw it up on the board and talk about it. OK, let's move ahead to the next chunk. And here, I'll talk a little bit more about the Music Lab, but more in the context of emphasizing zero variable cost experiments. Experiments that have these high fixed costs and low variable costs, and what kinds of things that helps you accomplish. OK, so so now we're going to really talk about experiments at scale. So there's this thing. I was at Stanford recently, and we talked to people about what they're working on, and they would say, "I'm working on such and such at scale." And like, no matter what they said, there was always "at scale" at the end. And so this is going to be about experiments at scale. And because to me, this is really one of the things that's most different, is the ability to do really, really large experiments. And I think it's one of the most exciting parts of it because with these really, really large experiments, we can potentially do stuff that no one has ever done before, and no one has even ever thought about before. Like, if you can do a really, really large experiment and you end up just doing the same thing everyone else has done 100 times, that's a real failure of imagination. So try to think more about like what is now possible that was not possible before. And I'll give a concrete example of that. So again, this is the way to think about cost scaling in analog experiments. They're relatively easy to start. They have a low fixed cost. And then if you want to double your experiment, you need roughly twice as much money. If you want to 10x your experiment, you need 10 times as much money. Here's what digital experiments look like. And again, this picture we see over and over and over again. And this, I think, comes up all over, but I think it's very important in experiments as well. So like for Music Lab, there was a high fixed cost, and then there was zero variable cost. And so what that allowed us to do is run experiments with 27,000 people, which, like, let's imagine we got every single undergrad at Duke to be in the experiment. How many undergrads are there at Duke? Like 5,000? 5,000, not enough. Let's imagine we got everyone at Duke and everyone in their family. That's like probably still not 27,000. Like 27,000 is a lot. I know that we're used to thinking on Facebook experiments have 100 million people or whatever. 27,000 people is a lot of people, and the only reason that is possible is because of this. And the other thing is that we didn't just take experiments that people had run before and do them 100 times. We tried to do something qualitatively different. So I want to talk here a little bit first about how to get this zero variable cost in your experiments, how you can create these experiments. And then also to think some about what are the ethical implications of this. Because I'm going to teach you how to do something, and you could then potentially misuse what I'm going to teach you. So I want to warn you about that possible misuse. So in the main sources of variable costs in experiments, I think are staff time and participant payment. So if you think about a Psych 101 experiment, which is kind of can be our sort of baseline for comparison, there usually is a person in that room with the participant, a grad student who is there to like greet the person and check them in. That is expensive. Graduate students are expensive. And you have to pay the participants to do it because they generally wouldn't just show up and do it on their own. So what if we could eliminate both of those costs? So we can automate the experiment so that it can run while we're sleeping. And we can design enjoyable experiments that people actually want to be in. And so if you're able to do automation, you eliminate the need for staff time. And if you're able to design enjoyable experiments, you eliminate the need for payments. So once you have an enjoyable, fully automated experiment, you get zero variable cost. So we talked some about building bots. That's a way that you can start to think about automation. A lot of websites completely run on their own without human involvement. That's another way to create automation. So in Music Lab, let me tell you about what we did. And you'll see these themes of automation and enjoyableness in the experiment. I also want to be totally clear. I wasn't like thinking about this at the time. It wasn't like I was like thinking about this picture at the time. This is all stuff that had become clear to me much later. I think implicitly this stuff we were thinking about it, but it certainly wasn't explicit. So this is a project that I did with Duncan Watts, who was a speaker a few days ago. He was my advisor. Peter Dodds was involved in this project, as was Peter Housel, who was a web developer we worked with. So this is also, there was a designer. Peter Housel did not make this. Cool picture. So we also had someone named Jason Burr-Jennings who helped us with the graphical design. Because the first thing that Peter made did not look cool, as Peter would totally acknowledge as well. So This is the website that people saw. They visited musiclab.columbia.edu. So you can see that it's very clearly labeled as something related to Columbia. So this is Columbia Blue. We have the university logo. It's hosted on a university website. So it's clear to people that they're in a research study. After people clicked here, then they completed a consent form. They took a short survey where we collected some basic demographic information about them. And then they were taken to a page that looked kind of like this. These are 48 songs from up-and-coming artists. A key feature about this design is that these bands are all unknown to the participants. So we wanted to have these bands be essentially blank slates where then we could control all the information people have about them. So if you imagine at the time Britney Spears was very popular and Justin Timberlake was very popular, he is actually still pretty popular too. That's pretty impressive. So if you put Britney Spears and Justin Timberlake's music into this experiment, people come with all kinds of stuff about them. Here, these are bands like Stunt Monkey, Not for Scholars, Parker Theory. These are bands that you have not heard of. And if you had been around in 2004, you would have not heard of them as well. This was actually an interesting sampling challenge of trying to find high quality, good music that was essentially unknown to participants. So we got these bands. All of the bands agreed to have their music in the study. And in part, this was for increasing exposure. But also, we gave them back market research. So what you'll see is people are going to interact with these songs and rate them and download them. And we have some demographic information. And so for each of the bands, we said, we'll get you some more exposure. And we'll send you a report about how people are interacting with your music. Yep. Yeah. So the bands, there was a website called purevolume.com, which was a place where unsigned bands posted their music. So we took a sample of these bands and contacted them, and the ones that agreed to participate were in there. So they were aware of what we were doing, and we, as I said, gave them exposure and also gave them these marketing reports. We also did a number of screens on Pure Volume to eliminate bands that participants might have heard of. So we eliminated bands that had played. So we had talked to, while I was doing this, I ended up talking to a bunch of people who knew about indie music, which I certainly did not when I started. And so I asked, what's a good way to figure out if a band is well known? And they said, if they've played in more than 10 states, that's a good sign that they're pretty well known. So on a lot of their Pure Volume pages, they list their gigs, and so we would take them out if they've played in more than 10 states. If they've played in certain music festivals, like South by Southwest, that's a sign that they're pretty popular. You should take them out, and so on and so on and so on. So there's a screening process and then a consent process. Yep. No, so this is actually, it's an interesting thing. So usually when you design an experiment, you kind of set all the parameters of the experiment. In this case, the parameter was set by nature, which is whatever was on purevolume.com, that's what we got. And so what you'll see is there is, well, let me add one more thing about the Pure Volume. So if you just look at all the songs, there's a lot of just really bad music. And I don't believe in objective quality in music. I mean very poor recording, just junky. So we limited ourselves to bands that were paying $10 a month to have their music. They get extra features on Pure Volume. So that is not a super high bar, but it rules out people that are not at all serious about what they're doing. And so of these bands that pay $10 a month, there's a big variety in quality, and there's a big variety in genre. And the big variety in attractiveness of the music is actually a parameter that I now think has an impact on what we found. I didn't think about it at the time. And so you could imagine doing a version of this experiment where you adjust the composition of the music in different ways. But in this case, it was sort of set by nature. Yeah? Yeah. Yeah, so how do we decide if they were high quality music? So we didn't want to be in making that decision in the same way that like with Kitten War, we don't want to decide what kittens are cute. We want to let other people decide. So this was a very crude process of just listening to stuff that was on there and then saying, okay, of the people that are paying $10 a month, these sound like they're well recorded. So there's a lot of music here that I do not like at all. But it was like well recorded. Yeah. But we didn't get into micromanaging each specific thing. We basically said, are you paying $10 a month? Then of the ones that are paying $10 a month, have you played in more than 10 states? We're going to get rid of you. Have you played in certain festivals? We're going to get rid of you. Then everyone else, we're going to take a random sample, and then we're going to contact you. And if you consent, you'll be in. And most of the bands that we reached agreed to participate. There were a very small number that didn't. And there were a number that we couldn't actually reach. But generally, bands who are paying $10 a month are really excited to get emails from people. So they're like, oh, you want to do stuff with our music? That's great. So generally, the responses were very fast and very positive. Yeah. Yes, there's absolutely heterogeneity of the music, and I'll talk a little bit more about how I think that might have impacted the results. So after you clicked on a song, it started to play. I want to also say this page, this took a lot of work to design. I know it looks like kind of natural, but like Jason did a lot of work to figure out how we could put so much information on the page and make it easy for a user. It didn't just happen. Okay, so then we click and it starts to play. And then you're asked to rate it on a scale of 1 to 5 stars. Just also technically, this thing about streaming the audio, we were very worried about if we could make this work successfully. Turns out we were able to, but at the time this was like a non-trivial technical thing. So you're asked to rate it on a scale of 1 to 5 stars. Then after you rate it, you have the opportunity to download it or not. And so the way we set up the experiment, we sort of, I think, focused people's attention on this decision. Like we're interested in understanding how people respond to music. And I think many of the participants thought that this was the decision that we were interested in, and this was kind of like the reward. But this was the decision we were actually very interested in, because here we have a very strong behavioral signal that you actually like the song. So whether you say, oh, 1 to 5, okay, but if you actually choose to download the song, that's a very strong signal of your actual interest. So at this time, I think this highlights something that you see a difference in experimentation in different fields. I think certain fields like psychology tend to be more willing to accept reported behavior or like what people say. And people in economics, for example, tend to be much more focused on what people do. And so here we're definitely focused on what people are doing. Although in the analysis, we see huge convergence between what people say and what people do. Then you're taken back here, and you're, again, given the choice to listen to, rate, and download as many songs as you want. So what the participants did not see is that behind them, there was an experimental design that was going on. And some of the people were randomly assigned. Let me explain why this design was going on. Because actually, I realized this whole talk, we didn't talk about the actual research motivations of what was happening. I was so focused on zero variable cost. OK, so what were the research motivations? It actually goes to a theme that we've discussed a lot here, which is unpredictability. And so we were really interested in things like Harry Potter. So that was very popular around then. And actually, Norah Jones was also very popular around then. OK, so the Harry Potter, incredibly popular, sells millions of copies around the world, translated into more than 60 languages. That would make you think that Harry Potter is somehow special, or better than all the other books, or at least somehow different. But that difference was not at all clear ahead of time to the publishing executive. So Harry Potter was rejected by 8 publishers before it was finally picked up. And it turns out that stories like this are very, very common, where you see huge success and also a lot of inability of experts to identify those things, failures of prediction. And more generally, it turns out that in the market for books, music, movies, art, and TV shows, you see 2 general patterns. One is you see huge variation in success. These are sometimes called winner-take-all markets or superstar markets. And at the same time, you see tremendous unpredictability in who will become successful. And so, like in movies, the screenwriter William Goldman says, nobody knows anything. And so it seems strange that these 2 things would co-occur, that you would simultaneously see huge variation in success and tremendous unpredictability. And so what we were trying to do is figure out if both of these collective level outcomes could arise from the same individual level process. And so that was the argument that we were making, that social influence, that people being influenced by what other people are doing, can create a process of cumulative advantage where successful things become more successful. And you can see how that leads to big variation in success, and how success leading to more success creates superstars. But also that success leading to more success can also create unpredictability, because sometimes one thing would become popular, and then if we could rewind history and play it again, a different thing could become popular. So this argument may be compelling to you, but only if you do not like Harry Potter. So everyone who likes Harry Potter is totally convinced that Harry Potter was destined for greatness. And the challenge is that, like, for Harry Potter, let's say, that one piece of data is completely consistent with the idea that Harry Potter is great, and it's completely consistent with the idea that Harry Potter is lucky. And so to see the role of chance, we really need to see multiple outcomes of the same process. So imagine if we could rewind the world to the day that Harry Potter was first released and make 8 copies of the world and have them all evolve independently. So if Harry Potter was popular in all of those, then we would say, okay, it's good. If it was popular in one, but not the others, then we would say it's lucky. So that's kind of a thought experiment, and we can't actually rewind the world. Even with the biggest grant from the Russell Sage Foundation, we cannot do that. So what we were trying to do but we can do something like that in an online experiment, where we can create these parallel histories, and we can compare these parallel histories when people are interacting with each other and see what other people are doing, compared to a history where everyone is behaving independently. And so this way we can isolate the effect of social influence on inequality and unpredictability of success.
So how did the participants interact with each other? Did they see the ratings of songs, or?
So the way the information that participants had about the other songs was the download counts. So I want to say something about this design also, because I presented this in a psychology department, and someone asked, well, where did those download counts come from? And I said, they came from our database. And they're like, no, but how did you pick them? And I'm like, oh, we didn't pick them. They just counted up how many times the things are actually downloaded. And they're like, you mean you didn't fake the download counts? And I'm like, no, this is just actually, we sort of set this system up and let it evolve naturally. So I want to emphasize, this is a bad design for studying social influence at the individual level. It's very hard to understand, given the way that we've set this up, why exactly people are doing what they're doing. How do we disentangle certain mechanisms involved in social influence? But that is not the goal, to understand individual level social influence. The goal is to understand what are the aggregate consequences when people are following what other people are doing. So another way to think about it is if you think about I like to think about so sometimes people ask, what is sociology? And so I sometimes say sociology is about packs of dogs. And then they say, what are you talking about? And so I'd say that you can think about an individual dog, and we can like ring a bell, and we can study if that can teach, we can train the dog to salivate when we ring a bell and do all this stuff about studying individual dogs. And we can study those individual dogs by themselves in great detail. But when we put those dogs together into a pack, new behavior emerges. And so I think as a sociologist, I'm generally interested in packs of dogs, not individual dogs. So we are not really isolating the precise things that are going on inside of people's heads as they make these decisions. We are instead trying to understand what the aggregate implications are for things like success and unpredictability, which are not the properties of any individual. They're the properties of the aggregation of many people's decisions. Okay, good. Many questions?
I mean, isn't it a problem that maybe actually these counts, they are highly correlated with the goodness of songs?
Great question.
Because I feel like it's, so what I mean by this, it kind of helps people, so probably people who started to use this website a lot, they actually understand things about music, yes? And so that helps them. So maybe these counts, they kind of trigger their interest, but they don't really like,
yeah, so one question might be, maybe these counts actually don't lead to increased unpredictability. Maybe they lead to increased predictability. So maybe there's just some good songs in here and some bad songs. And by showing the popularity, you're just going to help people find the best songs faster. So there's a lot of times where we think, like, wisdom of the crowds. Let's make information about what other people are doing available so people can learn from the behavior of others. So maybe this is actually going to lead to increased predictability. And we'll see what happens in a second. Other questions? Natalie, yeah? Are you about to explain what the 8 worlds were? Yes, I'm about to explain what the 8 worlds were. OK. Let me explain what the 8 worlds were. OK. So participants came to the website, and they were randomly assigned into one of these conditions. In the independent condition, they saw exactly what you just saw, but without the download count information. And so this is a world of people making decisions independently. This behavior of people in these conditions also gives us a great way to measure the appeal of these songs. So you notice I almost said quality, but I didn't say quality. So let me say why I didn't say quality. Because I don't really believe in objective quality. I think that attractiveness of artistic things is like a property of the object and a property of the receiver. So like if I like Jay-Z and you like Beethoven, like I don't want to have a discussion about which is higher quality. I'm just happy to know Beethoven is high appeal to you and Jay-Z is high appeal to me, and we can just all be happy with that. So a lot of studies about these cultural products, they run into this problem that they can't really measure the appeal or quality. So they try to say experts, give expert ratings and stuff. And I think that's like bogus. So what we were doing here is we were having the people in this pool of participants acting independently, whether they download these songs or not. And so then we can say, for this group of people who are mostly American teenagers, these particular songs are very appealing, and these particular songs are not appealing. And if we run the experiment with a different group of people, which in fact we did, we ran it with an older and more international group, they found different songs appealing. That's fine. So this condition gives us a measure of the appeal of the song, which I think is much better than measures that are based on experts. Then people were also assigned randomly, some people were into these social influence conditions, and then they were further assigned into one of these 8 worlds. And so what would happen is you would see the download count in your world, but you wouldn't see anything about what was happening in the other world. So imagine you go into, there's like 8 sort of dorm rooms. You go into one of the dorm rooms, you see what's happening in your room, but not in the other rooms. And then we can see to what extent these worlds with indistinguishable groups of participants evaluating the same 48 songs with the same initial conditions of 0 downloads, to what extent these evolve similarly, or to what extent these sort of parallel histories diverge. So I want to also say that we did 2 versions. We actually did 4 experiments, but I'm going to talk about 2 main versions that we did. So in one version, we had less social influence. So by presenting the songs in this way, the popularity of the songs was available, but it wasn't particularly salient. In this second condition, we sorted the songs by popularity. So we dramatically increased the amount of social influence. So what we're doing here is we're manipulating this individual level process, and then we want to see what effects that have on group outcomes. Now I want to talk 1 second about why we need so many participants, because each outcome is the result of a group now, not an individual person. And so in these first 2 experiments, we had 14,000 people, because each world had about 700 people. And so if you want to have 700 people to produce 1 data point, you're going to need a lot of people. Yeah, Hussein? Yeah. Yep, good question. OK, so within each experiment, it was done at the same time. Because what we were worried about is, so traffic on websites can sometimes be heterogeneous and bursty. So for example, if we got so we were also out trying to get links on like music blogs, and we're trying to get coverage in the newspaper, and we're trying to do all this stuff to get people to come to this website. And so let's imagine we get on this cool indie music blog, and then we have 100 people show up at one time, and they all get put into World 1, and then we have this we get in USA Today, and that's like a very different group of people, and then they all show up in World 2, then they're not really the same. So these are all happening simultaneously to ensure that the worlds were the same, even if there's heterogeneity in the arrivals. Let me talk about one of the challenges this creates, though, is how many worlds should we have? So we were like, we want to have as many worlds as we can, of course, but we don't know how long it's going to take for these popularities to stabilize. And we don't know even how many people we're going to recruit. So this was a very hard process. Basically, we did a pilot test to check and make sure the website worked correctly, and also to get a little bit of data. And then we ran some simulations, and then we kind of made a guess about how many people we could recruit. And that's sort of how we ended up with 8. But that was not in any way like optimized. It was just like us kind of trying to figure out what was possible. But it has this weird property that also, actually, this is something we talked about during the coffee break. How do you know when to stop? And so we didn't even know how long it would take to stop, because we had no idea how long it would take for the popularity of these songs to sort of stabilize. OK, so what did we? Oh yeah, so we did these 2 experiments. So this is what we found. All right, so there's a lot going on here. So this is the first experiment where we had less social influence, right here. So the x-axis here is the market share in the independent world. This is a measure of the market share is of all the downloads, what proportion of the downloads went to that song. The y-axis here is then the market share in each of the social influence worlds. So for example, this song here, this is She Said by Parker Theory. And it's a really good song. And you can see that for the 8 different worlds, there were 8 different market shares. So I want you to first look at this plot. And what you'll see is a couple patterns. So one you see is there's some inequality in success. Some songs are more popular than others, but not a huge amount. There's also some unpredictability in the sense of variation across here. So this kind of variation is kind of fundamental variation. It is like not resolvable. Even if you have perfect information about the appeal of the song, you can't possibly make this prediction. So because there's just inherent variability. In the same way, you can't predict what's going to happen if you roll a fair die. You just can't. It's inherent unpredictability. So this is what we saw in the first experiment. Then we cranked up the amount of social influence, and we wanted to see if this would increase the inequality of success, which it does. You see there's much greater variability in the popularity of the songs. And it also increases the unpredictability of success. So the variability for any particular song gets potentially bigger, but not uniformly bigger. So while I was doing this, while I was doing this, I talked to a lot of people who knew about stuff I didn't know about. And I think that's really valuable. People who are not professors. So I want to emphasize the value of that. So the whole idea of unpredictability being a thing in music, I learned that from my barber. So I was living in New York, and this, anyway, my friend had this barber who cut people's hair in her apartment. It was like, she was like into music, and like, so I was talking to her about my dissertation naturally, and so we were talking about the, inequality of success, and I was like, why are some songs so much more popular than others? Like, what is going on with Norah Jones? And she was like, well, you know that no one has any idea that Norah Jones is going to be popular. And I'm like, oh, come on, surely they knew, right? Norah Jones is great. She's like, no, like, no one knows. Like, when I worked at a record company, most of what we did failed. And like, I was like, really? And she's like, oh yeah, everybody knows that. I'm like, wow, that's great. I didn't know that. And so then I went back and I looked more in the academic literature, and I was like, oh, actually people have written about this before. This like is a big thing. I just didn't know. Anyway, so I thank Juliana for helping inspire my district. Juliana was my barber. The second thing is that once we started having results, then I had stuff that I could talk about with other people. And so I showed this result to someone who is the head of research at NBC. So NBC is a major television network in the US. And so I walked into his office. He has a beautiful office. Like, it's great, great view. And I was like, okay, I explained the experiment. This is what we did. This is what we found. And he said, oh, I knew that. And I'm like, you knew this? He's like, yeah, I knew that. I'm like, well, what did you know? And he's like, well, I can predict failure, but I can't predict success. And so I think that is the most beautiful way of summarizing what is happening here. So for the songs that are low appeal, they pretty much never do well. But for the songs that have high appeal, a huge range of outcomes is possible. So it's not that there is this, we talk about unpredictability, but it's much more subtle. That there's really a lot of unpredictability for a subset of the songs, and for other songs there's actually quite a bit of predictability that it won't do very well. So I think that's a great way of thinking about what's happening here, and it's consistent with some of the stuff that Sendel talked about yesterday about thinking about variability and the ability to do prediction across different ranges of people. Yeah?
What's market share? Like, how is it exactly?
So the market share is the total number of downloads for that song in that world divided by the total number of downloads in that world. Yep, Natalie?
Did you look at the growth of really popular songs within a given world? Like, is that a virtual attachment process, or is it something else entirely?
So there's two things that are happening. So if you think about how a song gets a download, there's two choices. So first, people have to decide what to listen to. And then given that they listen, they have to decide whether to download it or not. So the final outcome is a result of these two choices. So that makes it actually very hard to, right? So we observe both of them, but in some ways, it's very hard to understand this second choice because people have selected in the first step. But what I will say is we've done a number of things, and my guess as to what is happening, which is not 100% rock solid, is that most of what was happening is driven by the listening decisions and not the probability of download given listen. So in other words, when people think about social influence on choices, they often think about, imagine a world where you're in a bookstore and you're holding a book called Bit by Bit: Social Research in the Digital Age, which is currently available in all your bookstores. And you're like, wow, this is a great book. And you've heard that it was a great book, and so social influence would impact whether you're going to buy that book or not. But I think the much bigger effect is on what people even choose to consider. And that is a property of a lot of these markets for cultural products where there's choice overload. There's just too many things. And so given the enormous number of things, social influence plays a big role in what we even consider. And that highlights actually a second sort of hidden parameter in the design of the experiment, which is the number of songs. So we talked about the distribution of quality of the songs being a hidden parameter. So why did we have 48 songs? So the answer of why we had 48 songs is that that's the most songs we could fit on a screen without having scrolling in this design in experiment 1. So this is not a scientific reason exactly. And now, after doing the experiment, I think if we had had 4,800 songs, I think the unpredictability would have been much, much bigger, actually. This is, I think, another example of a hidden parameter in what we did. Yeah, do you have a question, Doug?
Does that then suggest that the choice set was much smaller, you might not observe unpredictability? Like,
Yes,
let's say,
I also think if you go the opposite direction, because essentially one way to think about it very crudely, this two-step process. And so there's the listening decision. I think that's where a lot of the social influence is happening. And then there's the download decision, which I think is affected a lot by the appeal of the songs. And so if the amount of social influence on the listening decision goes away because you can listen to all the songs, then the song attractiveness is going to dominate. If there's lots of stuff happening here, then this is going to dominate over this. And so we happen to end up with one combination of these with 48 songs, with the distribution of appeal of songs that were on pure volume at that time. And so I think you can see different ways of balancing these two forces if you had done slightly different versions of this experiment. Okay? Yeah, so one question is, were there geographic differences? So we don't know, but we do know. So we talked about the advantage of low variable cost experiments for dealing with questions about external validity. So as we were doing this, many people were concerned, oh, these are just American teenagers. American teenagers are particularly susceptible to social influence, perhaps. And so we completely replicated the study with a different pool of participants and got, in aggregate, very similar results. So if I showed you the plot from experiment 3, it would look kind of like this, but there is an important difference. Which songs were in which spots were different, but the overall distribution of the market was the same. So it also highlights the fact that there are certain social processes that change the distribution of reward, like the amount of inequality in society. And then there are other processes which can shape who goes into which spot in that distribution. And those are things that can be, those are different things and different mechanisms can be at work there. Okay, so this is, again, a number of decisions we made when designing Music Lab enabled it to be zero variable cost. So rather than paying people to do some task, we decided to make a task that was enjoyable, giving them free music. Now, by the way, this also I don't think would work as well today because people are kind of awash in free music. It's at the time, though, downloading music from the internet was kind of cool. That was a long time ago. Some of you might not even weren't even alive then, maybe. So like the strategies that you will use to make something enjoyable will evolve as society evolves. And here, zero variable cost was a means to do these really large experiments, which allowed us to have these group outcomes. And it wasn't just an end in itself. Like we weren't using free music because it was cheaper. We were using it because it enabled us to do something different. So I want to talk a little bit now about what can go wrong in zero variable cost experiments. Because, or not wrong, but how they're not really zero variable cost. They're not zero cost. They're zero cost to you, which is different than zero cost. So this is a study by some psychologists. And what they did is they sent professors emails kind of like this. Dear, I did not get this, but this was the contents of the email. Dear Professor Salganik, I am writing to you because I am a prospective PhD student with considerable interest in your research. I'm going to be visiting campus. I know it's short notice, but I'm wondering, I'm going to be visiting campus today. I wonder if you might have 10 minutes to meet with me to talk about my work. Sincerely, Carlos Lopez. Okay. So many of you may have a sense of what is going on here. So there's two things that they varied in this design. One is the name of the person sending you the email, and the other is the timing. So whether you're able to meet today or whether you're able to meet next week. And so what they're doing is measuring to the extent to which professors are more willing to meet with certain types of students than other types of students, and how this depends on whether the request is for today or whether the request is for in the future. So what you can see here is that actually when the request is for today, the meeting rates are similar between Caucasian male students and other students, but when the requests are in the future, there's a difference based on the characteristics of the sender. Because this is a zero variable cost to the researcher experiment, they're able to send out many variations of this, which is great. So you can imagine all the different conditions that you might want to do. And so they have a variety of different kinds of names and ethnicities. So let's think about what are the fixed and variable costs in this experiment. So to the researcher, it is free to send out more emails. Now, but that does not mean it's free to the world. So if you do an experiment like this with 100,000 professors, that is, let's say it takes 1 minute per professor to answer this email, then you are imposing a cost of 100,000 minutes on society. So in other words, when you think about costs, don't just think about cost to yourself. Think about cost to other people as well. So there's this difference between zero variable cost and zero variable cost to you, especially if these people are not opting in to be a participant in your experiment. So Music Lab, that took sometimes 5 to 10 minutes, but those people are choosing to be in it. Here, you're sort of conscripting people into your experiment, and so you should think carefully about the time. I want to point out these researchers were very aware of this issue. They have a discussion of it in their paper, which I think is great. They obviously went through IRB approval. They also debriefed participants. So debriefing is what happens when after an experiment is over, you tell them like, oh, hey, by the way, you're in an experiment. Some people may say, why debrief people? It just causes problems. Other people may say debriefing is consistent with transparency-based accountability. There are a number of debates about debriefing and whether it does more harm than good. Psychologists have thought about it a lot. There's some links to papers in Bit by Bit about debates around debriefing. But I just want to bring up this point about think about the costs on other people if you are conscripting them into your experiments. So I think we had a bunch of questions already. Are there any more questions? Yeah, let's have questions.
I really like Music Lab, and I'm just wondering if when you thought about IRB, you have two kinds of participants in that experiment. Did you also like the recruiting and communication with the bands? Is that something you had to think through ahead of time?
Yeah, that was all. That all went through IRB approval. All the stuff with the bands and all the stuff with the participants. Other questions? Yeah.
Hi. So it seems like in the previous presentation you framed this as building an experiment, not building a product. But it seems like here you're filling a need for the bands and you're filling a need for consumers who, like, I guess, want music. So like in designing the experiment, did you design it in a way, since it is like kind of a big in terms of cost, did you design it in a way that no matter how it panned out, you would have something that would be publishable or usable, like, or?
Yeah.
Because I could imagine a scenario in which you like did this big cost, and then at the end, it turns out like social influence isn't real or something.
Yeah, no, I think that's a great question. So a couple things. One is why I called it building an experiment and not building a product is because we never intended for it to continue to run after this particular experiment was over. So it's kind of a single use, which also makes it even crazier in terms of bearing all those fixed costs. So I guess to be totally honest, I guess we just all thought it would work. Like none of us really doubted that it was going to work. I mean, that was a little crazy. So I think ideally you do want to design your experiments, particularly to the extent that you have things with large fixed costs, such that they're interesting either way. I think we had talked about that, and I think the way we would have thought about it is that there were existing theoretical models about cumulative advantage leading to unpredictability. So you know about the QWERTY and Dvorak keyboard. Like there's a lot of technology lock-in kind of literature. That stuff generally involved a smaller number of objects, like 2 kinds of keyboards, and the beta and VHS VCR. So I think if there had been not lock-in, if there had been sort of everyone converging to similar things, I think that would have been potentially a relevant thing for those theories. I think it would have been a little bit less interesting, but I think there was enough disagreement about what might happen that either way it would be informative to some particular theory. Yep.
Hey, I was wondering on the audit studies, beyond the ethical questions of it, do you think the prevalence of audit studies, like I know in political science, everyone and their mother is doing an audit study right now, has an effect on people or the results you're going to get when these people that you are looking to study see the email and say, oh, it's just another political science experiment with an explicitly race signaling name or something to that effect?
Yeah, I think it depends on who the population is in the study. So I think to the extent that you're doing research on people who know about all these experiments, then I think potentially, but most people are not really aware of all of this stuff that's happening. So I think it's probably not a major concern for audit studies that are happening out in the wild. Okay. Cool. Any other questions? All right, so last thing I want to do is I want to talk a little bit about ethics, but I want to do it in a way that I think is really also about important new research areas. So this, depending on how you look at it, this could either be a talk about things I think are important in the future for research, or it could be a talk about ethics. But I think it's, so as you all know, I really like kittens. This is from Kitten War. But okay, so there's a lot of debate about, so I worked on this particular part of Bit by Bit around the time that emotional contagion, there's a lot of debate about emotional contagion, that experiment. And there was like, things kind of got locked into this argument like, we shouldn't do experiments on people without their consent. Or it's okay to do experiments on people without their consent. And it was just kind of like, not a lot of movement, just a lot of struggle, but not a lot of movement. And so I tried to think about how can we like come up with some way where we can sort of make progress that we would all agree on. And I actually have a neighbor who does research on animal. She's a biologist. She does research involving rats in her lab. And so we were talking about this, and she's like, oh yeah, well, we have this whole system for how to think about how we use rats in an ethical way, and not just rats, other animals. And so I was like, this is really interesting. So we talked about it, and it's like a lot of the stuff that they've come up with like gets us away from this question of it's okay, it's not okay, to more of a question of like, what's the best way to do it? And then we can all make progress on what's the best way to do it. So like many of you might think that under certain conditions, it's okay to do experiments involving kittens. Many of you also probably think under other conditions, it is not okay to do experiments with kittens. There are certain experiments that I could describe to you that you would think are horrific and that should not be done. And there are other experiments which I could describe to you that you think would probably be permissible. And so if that's the case, let's try to figure out under what conditions we think it's appropriate to do experiments with kittens and under what conditions it's not. And then maybe that can help us think more about experiments with humans. Obviously, humans and kittens are very different. But I think by taking it out of the context that we're used to and putting it into a different context, it might help us see things a little bit differently. So it turns out that people that do research with animals have thought very carefully about this. And there's this landmark book by Russell and Burke, The Principles of Humane Experimental Techniques, comes from 1959. And they talk about what they call the 3 R's: replace, refine, and reduce. And so replace is either eliminate the need for experiments or replace higher animals with lower animals. I don't know exactly how to describe it. Like, you shouldn't do it with a monkey if you could do it with a fruit fly. They have like a hierarchy of animals. I don't want to have, I'm not putting animals in a hierarchy. I'm just saying that's how they do it. Refine, you want to refine your, so like, let's put it in terms of kittens. You don't want to do it with a kitten if you could do it with a fruit fly. Refine, you don't want to make your treatment unnecessarily harmful to achieve your scientific objective. So if I told you that I was going to do something and then I was just going to like do a bunch of other things that were just painful to the animal that didn't have any scientific value, you would say, no, that's probably not a good idea. You want to refine your treatment to be as least harmful as possible. And then reduce. You want to use the minimum possible number of kittens in your study. You don't want to just have tons and tons of kittens go through this unnecessarily. All right, so now let's think about how these 3 R's might inform the way we think about experiments involving humans. So this is the emotional contagion paper. So I want to be clear about why I picked this paper to talk about these. I picked this paper because it's a well-known paper, and I think it illustrates these 3 ideas well. I'm not comparing this paper to doing certain experiments on kittens. As many of you know, as we talked about some in the ethics examples, so they took the content of people's news feeds and they randomly blocked posts with certain emotional words, and then they measured the effect of that on the words that people posted in the future. These are the results. So they found when they reduced the number of positive words in people's feeds, people posted fewer positive words and more negative words. And they found the opposite when they blocked negative words. Okay? So then there was a lot of concern about this paper. So let's talk about how the 3 R's might help us with thinking about this exact paper. So replace experiments with less invasive methods. So as many, around the time that emotional contagion experiment was happening, there was also an emotional contagion natural experiment. So for those of you who are social scientists, you are familiar with natural experiments. And so the idea with the natural experiment is that nature essentially creates the experiment for you. So you are not doing anything to make people sad. Nature is doing something to make people sad whenever it rains. So that was what they did here. So basically they said, if it's raining, this also deals with interference, actually. So their design was, let's imagine that you have a friend who lives in Seattle and it's raining in Seattle. That's going to make your friends, how does people in Seattle live stream? I hope it's not raining there. So if it's raining in Seattle, then your friend is more likely to post negative words and less likely to post positive words, and then they can study the effect of that on you. So nature creates a condition which creates the treatment that you want. And so they were able to study the effect of these positive and negative changes in the newsfeed based on things that the weather was doing. So this is generally better than the researcher themselves inserting themselves into the system to cause these treatments. Now, to be totally clear, natural experiments are not always as precise and clean and tight as are experiments that researchers control. So it's not like this is a free lunch, but it is a way that you could learn certain things without having to actually run the experiment yourself. Refine, you can refine the treatments to make them less harmful. And so here an example would be, rather than blocking posts, they could have boosted posts. So let me explain what I mean by that. So by blocking posts, one of the concerns that people had is that people might have missed important messages from their friends, because those could have been randomly blocked. So instead of that, they could have taken the probability that something would show up in the feed and increased it as a function of the content. And so then super important posts would be less likely to fall out of the feed. The posts that would have fallen out would have been the sort of the lowest of interest posts. So rather than doing blocking, they could have done boosting. And then let's talk about reduce. Reduce the number of participants. So this is, so the estimator they used was a difference of means estimator, and a different way that you could do it is a difference in difference estimator. So let me explain the intuition here. Imagine we were going to do a study about whether exercise promoted weight loss. And so we give people treatment to do exercise, and then we measure the weights of the treatment and control group, and we compare them. So there's going to be a lot of naturally occurring variability in people's weights. And so it's going to make it hard for us to detect potentially a small effect. So now if instead of comparing people's weights, we take their weight before the experiment, we take their weight after the experiment and create a change score, and then we compare these change scores. And so what that does is it removes a lot of the variability in the population, and it makes it easier for us to detect an effect with a smaller sample size. So this, in the case of emotional contagion, they have the posts of these people before the treatment, and so they could have tried to study these change scores rather than the absolute scores. So this would have, we don't know exactly in this case, but other research talking about using change scores in online experiments suggests that you can cut the sample size you need by a factor of 1/2. So it's not, in this case there were 700,000 people, could have cut it to 350,000 people. So why should we care about reducing the number of participants? So we've talked some about cost, which is good. We generally, the lower the cost of our experiment, generally the more experiments we can run, or the more we can learn about the world. Also, I think in this particular case, it's good to try to reduce the number of participants because of two things. First, there's uncertainty about whether the experiment would cause harm. So many people, it's unclear whether this treatment caused any harm to anyone. I think it's a relatively small treatment, but I don't know of all of those people what happened. I don't know. So there is uncertainty. Even people who think it didn't cause harm or wouldn't cause harm, I think should acknowledge that they don't really know. And then the second is that participation was not voluntary. So in these kind of settings, then I think we should try to minimize the number of participants. This is not to say that we shouldn't ever do an experiment where there's uncertainty about whether it will cause harm. Because as I've said before, there's lots of things that we can do to deal with uncertainty about digital age research. But if there is uncertainty, we should try to do it as small as we can. So one way to summarize these 3 R's, I think, comes from Spider-Man, one of my favorite superheroes. So this is from the first Spider-Man and the first comic book. And after his Uncle Ben died, he's very sad, and he says, oh, I wish I could have done more. I should have done more to save Uncle Ben. And then he walks away into the darkness, and it says he realizes that with great power, there must also come great responsibility. And so the power that comes from being able to observe the behavior of millions of people without their consent and awareness, and the power that comes from being able to do zero variable cost experiments means that there must also be responsibility. And I think the 3 R's are ways of thinking about how we can accept some of that responsibility. And they're also ways of thinking about humane methods as a real research opportunity. So they're potentially much more efficient than standard methods. So I could have come up here and said, I have a trick to show you that increases the power of your experiment, and I've developed a new statistical technique that increases the power of experiments. That is a research opportunity. I think this can also then stimulate a lot of really interesting research. So my favorite example of this is differential privacy, which is a research area in computer science and statistics, which is about how we can allow people access to aggregate patterns in data without revealing information about any particular person. So we might, for example, want to know that people who smoke are more likely to get cancer. We might want to view electronic medical records to learn that pattern, but we want to do it in a way that doesn't require us knowing whether anyone has cancer or whether any particular person has cancer or smoked. So differential privacy is a set of techniques that tries to allow researchers to learn aggregate patterns without getting access to micro-level records. It's a huge area of research. It's very interesting research, and it's an example of research that's motivated by concerns about privacy and more generally coming up with humane ways of doing research. So are there any questions about the 3 R's? Okay, so this brings us to a special moment in the Summer Institute. We're now finished with this stage of the process. All of the materials that we've been using for the teaching are posted. Oh, there's a question. All right.
Okay. The question is, Facebook provides an opportunity to create a lookalike audience for an experiment, perhaps to serve as a control group. I assume that it matches controls based on internet and interest and demographics. What do you think about this in relation to change in behavioral change?
So I would say, I don't know exactly. I would say that a couple things come to mind there. One is, I think in relationship to the 3 R's, we would want to be careful if we're doing an experiment on Facebook where people don't have consent. We want to do what we can to minimize that. Then I think, but obviously in certain conditions, this is a reasonable thing to do. We want to try to refine the treatment to make it as least damaging to people as possible, which, but also about this lookalike groups. So I would be personally very concerned about not knowing how that works exactly. So if you're going to use some system that is going to be a big part of your research process and you don't know how that system works, then I think that's a challenge. It's not an insurmountable challenge. So a number of people have been interested in using ad systems for experiments, for example, and that's great. But I think there's a big challenge if we don't know how the system works. It makes it hard for us to learn from it. OK, any other questions? OK. Now, I do want to say we are going through a transition. But before we leave this part, I want to remind you that all of the materials that we've used for the teaching, these are posted online. You are welcome and encouraged to go and reuse them for your classes. If you are teaching, you're especially encouraged to improve them, because we know they can be improved a lot. So please take what we've done, use it, make it better. That's great. That applies to everyone here in this room. That applies to everyone at the partner sites. That applies to everyone watching the live stream not at the partner sites. That applies to everyone watching this video 2 years from now. The material is available. Please use it. Thank you all very much.